My name is Anthony Crain, and I am here today to talk to you about test theory, in fact, something quite specific. Every now and then, an executive, or maybe even a peer, or somebody will say to you, or me, or your friends, hey, why didn't you find that in test, some kind of defect or whatever? And you hear that, and I'm here to tell you that that is actually a nonsensical question. Turns out that whenever we do tests of any kind of complex or even simple piece of software, there are more paths through that software to test than we could ever have time. So what you're always doing is something called subset testing. Okay? So when someone says, why did you find that in test? The answer is, well, because there's an infinite number of tests I could have run, and that just wasn't one of them. Okay? Well, why wasn't that one of them? Well, because our test theories didn't tell us that that was a good one to go for. Okay? And that's going to keep happening. There is no way to run every test. So today I'm going to do a little proof for you here on the whiteboard that shows why this is true, to help people start to understand, one, that you can't test it all, two, that there will be defects that can't be found, three, what the definition of subset testing is, and four, that it's all okay. Okay? So join me for a second here. Let's do a little coding. All right, not coding, but pseudocoding. So here's some pseudocode, and then I have an if statement, and if this is true, we'll do these lines here, then some more code, and then another if statement, and if this one's true, we'll do this here, and then some more final code there. Okay, look at that. You can be a coder too. Just get a pen, draw some lines. All right, so here I have a bit of code. Each of these lines is some kind of software commands, and we have two conditional statements that we only execute when these particular conditions are true. Very typical software. You probably know that already. You wouldn't probably be watching this video. Okay, so now what? When I do classroom stuff or in lectures, I ask the question, okay, so if you had to write tests for this piece of software, and what I wanted you to do was to touch every line of code just one time, what is the minimum number of tests that you would have to run in order to touch every line of code exactly one time? Go ahead and give it some thought. You can pause if you need to. Okay, are you back? Maybe you never left. Did you come up with a number? When I ask this question to my students, I get numbers all the way from the most common is 4. I often will get 3, 2, sometimes I'll even get 1, very unheard of, but it happens, very rare. I've heard as high as 8, okay? So what's the point? The point is I want to hire the tester whose testing techniques allow them to get the most amount of testing done with the fewest number of tests. That's part of test theory. When I was at Motorola, we took a class in test, and they actually showed us 10 different testing techniques to help us pick good subset testing. So like, for example, one was called boundary testing, and that said if there's a range that a value can be at, test one below, one above, test one below, one above on the two sides of the range, then take one or two from the middle. Notice that's a subset test, right? To test all of it, you'd have to test underneath, the number, above, all the numbers between, underneath, the number, all the ones above, all the ones below, and look at that, you just got to an infinite number of tests like that. And think about it. If you test, well, we'll get to that in a minute. All right, so taking a look at this code, the question I asked is how many tests would it take to run? Well, it turns out there's 3 levels of test coverage. And in fact, modern software tools, testing tools, will tell you how good you're doing on these. So here are the 3 levels. I'll write them down for you. So first off, we have something called statement coverage. Then we have the next level of difficulty up, branch coverage. And finally, we have something called path coverage, okay? All right, so these are the 3 levels, and I'm really asking specifically about this first level. If I wanted to touch every statement just one time, what's the minimum number of tests it would take? And by the way, it's very common for an organization to set a goal of 100% statement coverage because it's totally achievable. And what's cool is with the testing tools, you might run 1,000 tests, and it'll say to you, you only covered 30% of your code. And you're like, what? How is that possible? We ran 1,000 tests. The data that you're picking, the values that you're putting into your tests are such that only 30% of the code is activated. Then you have to look and figure out what other values I have to provide to activate the parts of the code we've never even seen yet. Like for example, if someone has no last name, you never did that test, and sure enough, there's a whole set of code dedicated to someone with no last name. That's what I'm talking about. Okay, so back to this. Did you get your number? Okay. The lowest number I've ever heard is 1. If that person was right, and you could do it with just one test, that's the person I want to hire. Because they're getting me the 100% statement coverage, 100%, with just one test. Incredible. Are they correct? Yes. All right, let me show you how. So here we have our code. We're going to set up the test data such that this first one is true, and that this one is true as well. If you set your test data such that these two conditionals evaluate to true, then look, you cover all the code here. The if is true, the code here, the if is true, and the code here. You literally cover it all with just two truths. So the correct answer in this case for the minimum number of tests to cover 100% of statements is one test. That's what we want PR developers to do, to figure that sort of thing out. Now, it is possible that when setting this true, this automatically becomes false, like this, maybe if last name, if no last name, they're opposite, so then you couldn't do it. But assuming that you can set them both to true, the correct answer here is it would take one. Okay. Now let's go to the next level, branch coverage, okay? The question here is, the goal here is that we want to test the true and false side of each conditional in our software. So how many tests would we have to run to test the true and false path of each of these guys, one by one? All right, go ahead and pause it if you need to. Welcome back, or not, whatever you did. It's your choice, free will, okay? Meanwhile, the correct answer, I often hear 4 at this point, but the correct answer is 2. So with just 2 tests, I can test every single branch, the true and false side. How? My second test case, or script, or whatever you want to call it, would be setting that to false and setting that to false. So now I have 2. This is my first test. Maybe this is test scenario 1, and then this is test scenario 2. So I have 2 tests that I've run now, the true test, the false test, and I have covered every statement at least once. I've also covered every branch. Interesting point, if you ever do cover 100% of branch, you automatically cover 100% of statement. It's impossible to cover 100% of branch without covering 100% of statement. I'm squinting my eyes because I wonder if it's really impossible. Theoretically, it's impossible. Prove me wrong. That's fun. Okay. So the last level then is path coverage. This is the hardest one of all of them. So how many tests would it take to cover every path through this? So what's a path? It's the combinations of trues and false. In fact, you might have been thinking that already, saying, oh, but what if I did true here and false there? Now you're thinking path coverage, the third and most difficult one, okay, to achieve. Most difficult one to achieve because there's so darn many of them, okay? So what's the answer? Have you figured it out? If you've ever seen like a truth table, you might already be kind of guessing the full table. If you're taking like an engineering course in software or something. The correct answer, by the way, is 4. So maybe you already had that figured out. And so what are the 2 missing tests? We have 2 of them already put down. The next one would be that this is maybe false and that's true. And then maybe that this is true and that's false. And there's your test 3 and test 4, okay? So look how simple this little bit of code is, right? Very, very simple code. And yet it takes 4 different tests to test every path through it. That's incredible. So what happens if we add just one more if statement? Here's where it gets exciting, okay? So we add one more if statement. Now, how does that change these answers, okay? Statement coverage. Do you know it? Can you get it? Yes, it's still 1. True, true, true. You've touched every statement and you're done. By the way, notice that my ifs don't have any any else statements on them. If there were else statements, that would mean that you only test some code when it's true and you have to only test the other part of the code when it's false. When you have else statements, the statement coverage approaches the branch coverage number. If every single if had an else, then it would be equal to branch because you'd have to execute both sides of the branch every time, and that's the same thing as branch coverage. So in this example, there were no else statements. That's what allows us to get this down to 1, just for example purposes. Okay, so how many statements would it take? Just 1. How many branches? You might think 3 because it was 2 for this and then 3, but it's actually, you can still do it with just 2. True, 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 false, false, false. You've tested the true and the false of every one of the if statements. Missing a lot of paths, that's true, but you got all the branches covered. That's still 2. Where it gets interesting here is path, which I told you is the hard one. So did you figure it out? You might be extrapolating the truth table, right? Adding more to it so that you can include this guy, right? And if you've done truth tables, you might already know the answer. Maybe you know how computers work and that it's all binary, and so there's powers of 2 involved. If that's the case, you're onto something. Turns out the shortcut to finding the number of paths, count the number of if statements. 2 to that power is how many tests you have to have. So 2 to the number of branches, okay? In this case, that would be 2 to the 3rd, because there's 3 ifs, and 2 to the 3rd is 8. So it would take you 8 tests to get through all of this, right? Wow. Okay, so look at what's happening here. Think about how many conditional statements you have in your software today. Each time you add an if statement, you are adding an order of magnitude. You were talking about an exponential curve of more tests to do. And this is why you can't test it all. This is why it's a subset. Now, my colleague Marianne Ollier is the one who inspired me to make this video today. And she said something once that just inspired my imagination. We were talking to a testing team who said, we're not given enough time to test. We don't have enough time to test. And if you think about that statement, given the fact that they're always testing a subset, it's a nonsensical statement. If you're given 2 weeks, you're doing a subset. If you're given 1 day, you're doing a smaller subset, but it's still a subset. So when they say I don't have enough time, what they're really getting at is their subset isn't big enough to really understand the overall quality of the solution. But they're probably not thinking of it that way, unless they're really, advanced test thinkers, in which case, great, you got the right one. Okay, so think about this. What she said to them, and this is what I loved, what she said to them is, okay, imagine you could only run one test. What would that test be? And they're like, God, what do you mean one test? By the way, God, that's her word. She loves saying God, so I've told it from her. If you only run one test, what would it be? And they said, well, we wouldn't feel comfortable. She's like, yeah, but what if? What if you can only run one test, and if it fails, you don't release, and if it passes, you release? They're like, okay, one test to decide. And so they came up with it. She goes, great, she wrote it down. What if you could have 2 tests, 3 tests, 4 tests, and they start adding more? And so they start to realize the pattern here, right? Instead of feeling like you're limited when you have less time, it should be not limited, it should be additive. Think about the one test and then keep adding, using all those test techniques like the 10 I learned at Motorola. You keep using your techniques to find another one and another one and another one, right? So whether it's boundary testing, right? Whether it's value set testing, whatever you want, use that to add more tests until you are at the point where you're comfortable. Now, think about what this means. It means that the job of the tester isn't to find every defect, because you can't. Let's say that you run tests against 100 lines of code and you find 1 defect. And it turns out there's 1,000 lines of code total. Well, if you found 1 defect in 100 and there's 900 you haven't found tested yet, there's likely 9 defects you haven't found. And because it's always a subset, that means there will always be far more defects you didn't find than defects you do find. Now, we always fix the ones we find. It'd be negligent not to, right? But the defects we don't find are generally order of magnitude higher than the defects we do find, because it's always a subset of tests. Okay? So when that executive says, why don't you find that in tests? Say, well, because if you look at the mathematics of it, we're only going to find 10% of all the defects. Our job isn't to find all the defects. Our job is to tell you your overall defect density. Okay? So defect density is how many defects there are in all the stuff, even the stuff we didn't test. Okay? And what is the job of the tester then? Not just defect density, but here's my favorite thing. You're not there to find defects just so we can fix them. We will fix them. You're there to find defects so we can talk about it and figure out how did the defect get there in the first place. IBM created a term called ODC for orthogonal defect classification. Terrible name, incredible idea. I call it defect prevention. I think it's simpler to remember and say. Either way, ODC or defect prevention, your job is to look at all the defects you do find, because you know that there's way more you didn't, all the paths you can't cover. You look at the defects that you did find, and you say, oh look, a lot of them are of this type. What can we change to eliminate that type? If you eliminate that type, it's eliminated not from the ones you found only, but also from the 90% you didn't find. Those are not there because they never got injected because we fixed the upstream process. I'm going to do a video just after this one called The Mercury in the Lake. I hope you watch that one. It's a beautiful analogy on how what I just described works and what to do about it. But in the meantime, I'm hope now that as you see this, you realize a few things. One, you can't test it all. By the way, we only talked about if statements, right? If you count up the conditional statements to 2 to that power, that's the number of tests. Think about this. A loop, if you go through a loop 0 times, that's a different test than 1 time, then 2 times, then 3 times. So if you have a loop that can go anywhere from 1 to 10, that's 11 different tests, okay? Furthermore, if you don't test all of them, it's possible that when you go through the loop 5 times, it causes a defect somewhere in the code. Not when you do 6 or more, not when you do 4 or less, just 5. And if you don't happen to test 5, you'll never find it. That's an example of why it's an infinite number of tests. So once you have a loop, and let's imagine the loop is indeterminate. In other words, you can go through that loop as many times as you want and quit when you're ready. Now, the number of tests is literally, test paths is literally infinity. Because you have an infinite number of times you can go through, 2 to infinity is just a bigger infinity, okay? If that makes any sense. So, I hope now you realize, every time you're testing, you're subset testing, it's silly to say I don't have enough time to test. You never do. Although I do agree that testers should be given appropriate time. But what the definition of appropriate time is what's going to be fun to define now. And that because you're always doing subset testing, your job isn't to find defects. Sure, we'll do that, but it's to prevent defects in the first place. So hopefully that did it all for you. I don't think there's any more to cover. So my name is Anthony Crain, and I hope you enjoyed this lesson in Journey and Test.